Okay, today we're going to go through notes about the sun. This is starting off our solar system unit. We'll talk about the sun, different planets, black holes, galaxies, and different things like that. So we'll start off with the sun, which can be defined as a big ball of burning gas and dust that is millions of miles away. So the bright thing you see in the sky. Let's learn a little bit about it. So some properties of the sun. If you think of the sun as the size of an average front door, the Earth would be the size of a nickel. So that kind of gives you a size comparison. The sun is 110 times larger than Earth. The sun is a star, just like there's many of stars in the Milky Way galaxy. The sun is just one of them, but it is our star in our solar system. It is labeled a G2 star, which is just a category of stars, and we'll talk about that when we actually get into our stars section of this unit. But it is huge compared to Earth. The mass is 745 times more than the Earth's mass. The light that comes from the sun to Earth takes about 8 minutes and 20 seconds to reach the Earth, so that kind of shows you how far away the sun is from the Earth. And then the sun's temperature is about 5,500 Kelvin, which is about 10,000 degrees Fahrenheit. And that's temperature on average. We'll talk about the temperature of the center of the Earth and some of the other layers as well. So the sun does have an atmosphere. It is made up of it's basically another gaseous body in our solar system. It has four main parts. The first one being the core. The core is found below the photosphere. The photosphere is known as kind of the surface of the sun. So the core is below that. And this is where all of the energy is made for the sun. It's where nuclear fusion happens. And we'll talk about nuclear fusion in a little bit. So the reason that light comes from the sun is because of the nuclear fusion that's happening in the core. The core's temperature is about 27 million degrees Fahrenheit. It's pretty warm. Then we have the photosphere, which is about 400 kilometers thick, which is about, if you think about it in miles, 249 miles thick. It is the surface of the sun. It's made of millions of little gas bubbles that are called granules. Each of these granules or gas bubbles lives about 8 minutes. So that's how long they last, and then other granules will form. They rise up from the core and then they sink back down. So the core is super hot. So as they cool off, they rise up and then they sink back down and get hot again, and it's just a cycle. The next layer is the chromosphere. So this is the area that's above the photosphere, so a part of the atmosphere. It's the middle layer of the atmosphere. It is thousands of kilometers thick, which would correlate to thousands of miles thick. And then if you were to look at the chromosphere, it would look as if it has a reddish glow, and it is what moves the heat from the photosphere into the corona. The corona being the outermost layer of the sun's atmosphere. We can only see the corona during a total eclipse. It looks like a faint light surrounding the sun. So you can see here in this image, there's a total eclipse, and the corona is shown as shining around the sun, which you cannot see because the sun's too bright just during the day or any time. So you only see it during a total eclipse. The corona is about 3.5 million degrees Fahrenheit, which is actually hotter than the surface of the sun. They're not totally sure why that happens. There are some theories, but again, it's just one of those things in space science that I'm not totally sure how it works yet. So then we talk about sunspots. We've already kind of talked about sunspots when we talked about what Galileo saw when he looked to the sky. So the first person to see the sunspots was Galileo. Sunspots are dark spots that are on the photosphere, so the surface of the sun. The only reason they are dark is because the area around them is hotter and it glows brighter. So the sunspots are actually a cooler part of the sun, but they're still really, really hot. They do occur in pairs. They think that has something to do with the electromagnetic field because the sunspots correlate with stronger areas of the electromagnetic field of the sun. They also move from left to right across the surface of the sun. This is caused by the sun's rotation. That's why they move the way they move. There can be very many sunspots at a time or very few at a time, and it does happen on in a pattern. So the repeating pattern is called the 11-year sunspot cycle. If you look at the graphs at the bottom, they're time scales. So you can see over time the number of sunspots go up and then they go down and go up and then they go down. So if you looked at the year range there, it would be about every 11 years they go up and then they go down. And then 11 years later it goes up and then it goes down. So that's how it gets the 11-year sunspot cycle. So the regions where convection is inhibited, the corona heats up and emits more stuff towards the Earth. So we have solar minimums and solar maximums that have to do with how much stuff actually comes towards the Earth from the sun, and that all deals with sunspots as well. So then we're going to just talk about some solar stuff that deals with the sun. Corona holes is the first one. So this is what actually allows solar wind to escape from the sun, and all that energy can then come towards the Earth. Solar wind specifically is the gas from the sun's atmosphere that is escaping and blowing away from the sun. It can blow past the Earth at about 300 to 800 kilometers per second. Luckily, the Earth is protected by its own magnetic field, so solar wind doesn't impact us. But if people go outside of Earth's main area, they do have to watch out for their radiation because it can be very harmful to humans. Then we have solar flares. Solar flares are what interacts with the gases in our atmosphere to cause the auroras at the poles. So it's sudden eruptions of X-ray, UV, or visible radiations, and these events last normally about an hour. And it's a sudden brightening above a sunspot cluster. And lots of energy is released from these solar flares. Our next one is a prominence. A prominence actually looks like an arching cloud that's extending from the photosphere into the corona, and it's just a bunch of material in the corona that's condensing together to form this arch-like structure of plasma and hot gas. So how does the sun actually make energy? So it makes energy through nuclear fusion. Nuclear fusion is a process, it's more of a reaction that combines light nuclei into heavy nuclei. So in the sun, it specifically fuses hydrogen into helium. So the fuel of the sun is hydrogen, and it takes all that hydrogen and it goes through nuclear fusion, creating helium. And then over time, it can create larger elements as well. It's called the proton-proton chain reaction, which is how it goes from helium to hydrogen. That's what they call it. And according to different calculations, the magic temperature where the fusing of hydrogen into helium can actually begin is 5 million degrees Kelvin. So super hot. If you look at this image, it shows the different layers of the sun and just how it would radiate out as it would go through these different cycles. So it takes specifically 4 hydrogen nuclei to fuse together to form a helium nuclei. The matter is converted into energy, so that's where all the energy comes from in the sun. And then it takes about 600 million tons of hydrogen each second to form into different elements such as helium. The sun does have enough fuel to last another 5 billion years. So the reason that the sun can do this is because the sun being so large and having such a high amount of mass, it has a lot of gravity. And because it has so much gravity, it has a lot of pressure. So all that pressure causes the hydrogen atoms to collide together with enough force to combine to create that helium. So that's kind of how the process of nuclear fusion works in the sun. And where it specifically happens, it happens in the core. So below the photosphere, which again is the surface of the sun, these processes are happening in the core, where the energy is transported out from the core after the process happens by convection, which is also what happens in the Earth's mantle, the convection process. So it's like a cycling of the material. So that concludes the sun notes. You should be able to go ahead and do your problem set and answer all the questions. So make sure you email me any questions that you may have.